We have started the Petroleum Engineering series. The first 30 sections have already been covered in the previous videos. If you have not watched the previous videos, we would highly recommend you to watch them. The links are in the description. However, the sections taught in this video do not rely on any background knowledge. Also, if you desire, then you can jump over the other sections. The timelines are available in the description of this video. Section 31. An overview of the role of international and cross-cultural collaboration in petroleum engineering. The petroleum industry is a global business that requires collaboration and cooperation among professionals from different cultures and backgrounds. As such, understanding the role of international and cross-cultural collaboration is essential for petroleum engineers who want to succeed in this industry. International and cross-cultural collaboration in petroleum engineering involves the exchange of knowledge, ideas, and technologies across borders and cultures. It requires professionals to work together to find innovative solutions to problems that are often unique to different regions of the world. One of the most significant benefits of international and cross-cultural collaboration is that it helps to reduce knowledge gaps and increase access to expertise. This is particularly important in the petroleum industry, where professionals need to have a deep understanding of geological and engineering concepts to make informed decisions. International and cross-cultural collaboration in petroleum engineering also helps to foster innovation by bringing together different perspectives and approaches to problem solving. This is particularly true when it comes to finding new oil and gas reserves, which often require new technologies and techniques. Another important aspect of international and cross-cultural collaboration in petroleum engineering is the exchange of best practices. By learning from one another, professionals can identify and adopt the most effective and efficient methods of exploration, production, and distribution of petroleum products. To succeed in international and cross-cultural collaboration in petroleum engineering, professionals must have strong communication and intercultural skills. This involves being able to understand and respect different cultures, languages, and communication styles. It also requires professionals to be flexible and adaptable, as they may need to navigate different regulatory and business environments. In conclusion, international and cross-cultural collaboration is a vital aspect of the petroleum industry. It enables professionals to work together to find innovative solutions to the unique challenges faced by the industry in different regions of the world. To succeed in this industry, professionals must develop strong communication and intercultural skills and be willing to learn from one another. With these skills and a commitment to collaboration, petroleum engineers can make significant contributions to the growth and development of the industry. Section 32. Understanding the different types of petroleum industry contracts and negotiation strategies. The petroleum industry is one of the most complex and interconnected industries in the world. From exploration to production, transportation, and refining, there are various contracts and agreements involved. In this article, we will explore the different types of petroleum industry contracts and negotiation strategies. Petroleum industry contracts. The petroleum industry relies on a wide range of contracts to facilitate operations. Some of the common types of contracts include 1. Exploration and Production Agreements (EPAs). These contracts are used between a host country and an oil company to explore and produce oil and gas resources. EPAs typically cover the fiscal regime, exploration and production terms, and operational requirements. 2. Joint Operating Agreements, JOAs. JOAs are used between two or more companies to jointly operate an oil and gas field. JOAs typically cover the governance structure, decision-making process, financial obligations, and operational requirements. 3. Service Agreements. Service agreements are used between oil companies and contractors for specific services such as drilling, construction, and maintenance. 4. Transportation Agreements. Transportation agreements are used to transport oil and gas from production sites to refineries or other destinations. These agreements typically cover the transportation method, transportation rates, and other relevant terms. 5. Sales and Purchase Agreements, SPAs. SPAs are used between buyers and sellers of oil and gas to define the terms of sale and purchase. SPAs typically cover the price, quantity, quality, and delivery terms. Negotiation Strategies. Negotiation is an important aspect of the petroleum industry as it determines the terms of the various contracts involved. Here are some common negotiation strategies. 1. Preparation. It is important to prepare well for negotiations by gathering relevant information and understanding the other party's interests and priorities. 2. Collaboration. Collaborative negotiation strategies involve working together with the other party to find a mutually beneficial solution. This strategy involves focusing on the interests of both parties rather than just one. 3. Competition. Competitive negotiation strategies involve taking a more aggressive approach, often with the goal of achieving a better deal for one party. This strategy involves using leverage, power, and other tactics to gain an advantage. 4. Compromise. Compromise negotiation strategies involve finding a middle ground between the interests of both parties. This strategy involves making concessions and finding a solution that satisfies both parties. Conclusion. The petroleum industry is a complex and highly regulated industry that relies on a wide range of contracts and negotiation strategies. Understanding the different types of contracts involved and the negotiation strategies can help companies make informed decisions and achieve mutually beneficial outcomes. It is important for companies to engage experienced legal and business professionals to navigate the complex landscape of petroleum industry contracts and negotiations. Section 33. An overview of the role of digitalization and automation in petroleum engineering. As the world's demand for energy continues to grow, the petroleum industry must adapt to meet new challenges and maximize efficiency. One key way that the industry is doing this is through the use of digitalization and automation. By leveraging new technologies and strategies, companies are improving their ability to explore, produce, refine, and distribute petroleum products. In this article, we will provide an overview of the role of digitalization and automation in petroleum engineering. Digitalization in petroleum engineering. Digitalization refers to the process of using digital technologies to capture, store, and analyze data. In the petroleum industry, digitalization is used to monitor and optimize production processes, identify new reserves, and improve the efficiency of drilling operations. By using sensors, machine learning algorithms, and other tools, petroleum engineers can gain a more detailed and accurate view of their operations. One key area where digitalization is making an impact is in the field of reservoir engineering. Digital tools allow engineers to create detailed 3D models of reservoirs and simulate fluid flow, allowing for better predictions of production rates and recovery. Additionally, digitalization is being used to monitor well performance and detect early signs of problems, such as leaks or mechanical issues. Automation in petroleum engineering. Automation refers to the use of machines and software to perform tasks that were previously done by humans. In the petroleum industry, automation is being used to streamline processes and reduce the risk of human error. For example, automated drilling systems can perform precise operations with minimal supervision, reducing the likelihood of accidents and improving efficiency. Another area where automation is making a difference is in the field of maintenance. Predictive maintenance systems use machine learning algorithms to analyze data from sensors and identify potential equipment failures before they occur. This helps companies avoid unplanned downtime and reduce the cost of maintenance. Overall, the role of automation in petroleum engineering is to improve safety, efficiency, and accuracy. By taking advantage of advances in technology, companies can reduce costs, increase production rates, and minimize environmental impact. Challenges and opportunities. While the benefits of digitalization and automation are clear, there are also challenges associated with these technologies. One major issue is cybersecurity, as digital systems are vulnerable to hacking and other forms of cyber attacks. Additionally, some workers may feel threatened by the use of automation, as it could lead to job loss or reduced job security. Despite these challenges, the opportunities presented by digitalization and automation are significant. By leveraging new technologies, companies can increase their competitiveness, reduce costs, and improve safety and sustainability. To make the most of these opportunities, companies must invest in the right tools, develop a clear strategy for implementation, and provide adequate training to their employees. Conclusion. In conclusion, digitalization and automation are playing an increasingly important role in petroleum engineering. By using these technologies, companies can improve safety, efficiency, and accuracy in exploration, production, refining, and distribution processes. While there are challenges associated with these technologies, the benefits are significant, and the petroleum industry is well positioned to take advantage of the opportunities presented by digitalization and automation. Section 34. A Guide to the Basics of Petroleum Reservoir Simulation and Modeling. Petroleum reservoir simulation and modeling is a crucial aspect of petroleum engineering. It is a method of creating a numerical model of a reservoir to predict how it will perform over time, allowing engineers to optimize production and recovery. In this article, we will provide a guide to the basics of petroleum reservoir simulation and modeling. Reservoir simulation is a computer-based technique that uses mathematical models to simulate the behavior of fluids in a petroleum reservoir. The models are created based on data obtained from geological surveys, drilling, and production wells, and various physical and chemical properties of the reservoir. The simulation models allow engineers to test various scenarios and predict how the reservoir will respond to different conditions. The primary purpose of reservoir simulation is to optimize production by predicting the performance of the reservoir over time. The modeling process involves creating a 3D model of the reservoir, defining the reservoir's boundaries, properties, and fluid flow properties, and then running simulations based on different scenarios, such as well placement and production rate. There are different types of reservoir simulation techniques used in petroleum engineering, including black oil simulation, compositional simulation, and thermal simulation. Black oil simulation is used for reservoirs with high gas-to-oil ratios, while compositional simulation is used for reservoirs with complex fluid compositions, such as sour gas or heavy oil. Thermal simulation is used for reservoirs where heat is injected to reduce the viscosity of the oil and improve production. Petroleum reservoir modeling involves creating a 3D representation of the reservoir and its properties using specialized software. The models include geological and geophysical data, well data, and other relevant data, which is integrated to provide a comprehensive view of the reservoir. The modeling process involves several steps, including data preparation, model construction, and simulation. Data preparation involves gathering all relevant data and checking its quality, while model construction involves creating a 3D representation of the reservoir's structure and properties. Simulation involves running various scenarios to predict the behavior of the reservoir over time. In conclusion, petroleum reservoir simulation and modeling is a critical aspect of petroleum engineering that plays a vital role in optimizing production and recovery. It involves creating a numerical model of the reservoir and running simulations based on different scenarios to predict how the reservoir will perform over time. Different simulation techniques are used depending on the reservoir's characteristics, such as black oil simulation, compositional simulation, and thermal simulation. With accurate simulation and modeling, engineers can optimize production, reduce costs, and increase the recovery of oil and gas reserves. Section 35. An introduction to the principles of petroleum geophysics and geochemistry. Petroleum geophysics and geochemistry are two fields of study that are integral to the petroleum industry. They are focused on understanding the physical and chemical properties of rocks and fluids in the subsurface, which is essential for identifying and developing petroleum resources. In this article, we will provide an introduction to the principles of petroleum geophysics and geochemistry, and their role in the petroleum industry. Petroleum geophysics. Petroleum geophysics is the study of the physical properties of rocks and fluids in the subsurface. The primary goal of petroleum geophysics is to use geophysical methods to locate and characterize subsurface hydrocarbon resources. Some of the key geophysical methods used in petroleum exploration and production include seismic imaging, electromagnetic surveys, gravity surveys, and magnetic surveys. These methods are used to create images of the subsurface that can be used to identify and map geological features that may be indicative of hydrocarbon deposits. Seismic imaging is the most commonly used geophysical method in the petroleum industry. It involves sending sound waves into the ground and measuring the time it takes for the waves to reflect back to the surface. By analyzing the reflections, geophysicists can create a 3D image of the subsurface that can be used to identify the location, size, and shape of hydrocarbon deposits. Electromagnetic surveys are another important geophysical method used in petroleum exploration. These surveys involve sending an electrical current through the subsurface and measuring the response. By analyzing the response, geophysicists can identify the location and extent of hydrocarbon deposits. Gravity and magnetic surveys are used to measure the density and magnetic properties of rocks in the subsurface. These properties can be indicative of the presence of hydrocarbons, as well as other geological features. Petroleum geochemistry. Petroleum geochemistry is the study of the chemical properties of rocks and fluids in the subsurface. The primary goal of petroleum geochemistry is to understand the origin, composition, and distribution of hydrocarbon resources. Petroleum geochemists use a variety of methods to analyze the chemical properties of rocks and fluids, including chromatography, mass spectrometry, and nuclear magnetic resonance. These methods can be used to identify the type and quality of hydrocarbons present in a reservoir, as well as the source of the hydrocarbons. For example, petroleum geochemists can analyze the isotopic composition of the hydrocarbons to determine their source. Hydrocarbons from different sources have distinct isotopic signatures, which can be used to identify the source of the hydrocarbons in a reservoir. Petroleum geochemists can also analyze the thermal maturity of the rocks in a reservoir to determine the quality of the hydrocarbons. As rocks are buried and subjected to heat and pressure, the hydrocarbons they contain undergo a process called maturation, which can result in the formation of higher quality hydrocarbons. Conclusion. In conclusion, petroleum geophysics and geochemistry are two important fields of study in the petroleum industry. They are focused on understanding the physical and chemical properties of rocks and fluids in the subsurface, which is essential for identifying and developing petroleum resources. Geophysical methods like seismic imaging, electromagnetic surveys, gravity surveys, and magnetic surveys are used to create images of the subsurface that can be used to identify and map geological features that may be indicative of hydrocarbon deposits. Petroleum geochemists use a variety of methods to analyze the chemical properties of rocks and fluids in a reservoir to determine the type and quality of hydrocarbons present, as well as their source. This information is essential for understanding the potential of a reservoir and developing strategies for its production. Section 36. Understanding the different types of petroleum reservoir characterization and analysis techniques. Petroleum reservoir characterization and analysis is an essential step in the exploration, development, and production of oil and gas resources. It involves the study of various parameters to understand the geological and petrophysical properties of the reservoir. This understanding is crucial in determining the most effective methods for oil and gas recovery. There are various types of petroleum reservoir characterization and analysis techniques, which include 1. Seismic surveys. Seismic surveys are used to identify the structure and properties of the subsurface. The technique involves sending acoustic waves into the earth and analyzing the reflected waves to build a detailed image of the subsurface. Seismic surveys can provide critical information on the location, shape, and size of a reservoir. 2. Well logging. Well logging is a technique used to measure the physical properties of rocks and fluids in a borehole. The measurements obtained from well logging can provide information on the type of rocks present, their porosity, permeability, and the fluid content in the reservoir. 3. Core analysis. Core analysis is the study of rock samples from a reservoir. The technique involves taking cylindrical rock samples from the reservoir, which are then analyzed in a laboratory. Core analysis can provide vital information on the porosity, permeability, and fluid content of the reservoir. 4. Reservoir modeling. Reservoir modeling is the process of creating a computerized representation of the subsurface. The model can be used to predict the behavior of the reservoir and optimize the recovery of oil and gas. 5. Pressure transient analysis. Pressure transient analysis involves analyzing pressure changes in the reservoir. The technique can provide information on the location and extent of the reservoir, the permeability of the rock, and the fluid content. 6. Production logging. Production logging is the measurement of fluid flow in a wellbore. The technique can provide information on the productivity of the well, the location of fluid entry points, and the fluid content. 7. Well testing. Well testing is the process of analyzing fluid and pressure data from a well. The technique can provide critical information on the flow rate, pressure, and fluid properties of the reservoir. In conclusion, petroleum reservoir characterization and analysis is an important aspect of the oil and gas industry. It involves the use of various techniques to determine the properties and behavior of a reservoir. Understanding the different types of petroleum reservoir characterization and analysis techniques is crucial in optimizing the recovery of oil and gas resources. Section 37. An overview of the role of sustainability and environmental protection in petroleum engineering. As the world's population grows, so does the demand for energy. Petroleum, also known as crude oil, is one of the world's primary sources of energy. Petroleum engineering is the field that deals with the exploration, production, and processing of petroleum. With the increasing awareness of climate change, petroleum engineers are focusing on sustainability and environmental protection. In this article, we will provide an overview of the role of sustainability and environmental protection in petroleum engineering. Environmental concerns related to petroleum engineering arise primarily from the drilling, extraction, and transport of petroleum, which can lead to soil, water, and air pollution. Sustainability and environmental protection practices aim to mitigate these environmental impacts. One important aspect of sustainability is the reduction of greenhouse gas emissions. Carbon dioxide, which is produced by the burning of petroleum products, is one of the major contributors to climate change. Therefore, the petroleum industry is striving to reduce its carbon footprint through various means, including the use of cleaner fuels, carbon capture and storage, and the development of renewable energy sources. Another key element of sustainability is the responsible use of natural resources. Petroleum engineers are developing innovative methods to extract oil and gas reserves more efficiently, with minimal damage to the environment. For example, directional drilling and hydraulic fracturing, also known as fracking, have enabled the recovery of previously inaccessible reserves. In addition, the development of natural gas, which is a cleaner burning fuel than petroleum, is another strategy to reduce the environmental impact of petroleum use. Environmental protection is another important aspect of petroleum engineering. The petroleum industry is subject to various regulations that govern the protection of the environment. Petroleum engineers must work closely with environmental scientists and regulators to ensure compliance with these regulations. For example, companies are required to perform environmental impact assessments before starting drilling operations to assess the potential impacts on the surrounding ecosystems. Furthermore, the petroleum industry is actively engaged in efforts to clean up and remediate sites that have been contaminated by petroleum-related activities. This can include the cleanup of oil spills, the removal of abandoned oil wells, and the remediation of contaminated soils and groundwater. In conclusion, sustainability and environmental protection are essential components of modern petroleum engineering. Petroleum engineers are working to reduce the industry's carbon footprint, use natural resources more responsibly, and comply with regulations to protect the environment. As the world continues to rely on petroleum as a primary source of energy, it is crucial that the industry remains committed to sustainable and environmentally responsible practices. Section 38. A Guide to the Basics of Petroleum Industry Innovation and Technology Development. As the world's energy demands continue to rise, the petroleum industry is constantly seeking new and innovative ways to meet the growing demand. Innovation and technology development play a critical role in ensuring the industry's future success, as they enable more efficient and sustainable production, as well as improved safety and environmental protection. Here is a guide to the basics of petroleum industry innovation and technology development. 1. What is innovation in the petroleum industry? Innovation in the petroleum industry refers to the development and implementation of new technologies, processes, and ideas that help to improve the industry's efficiency, sustainability, and safety. This can include the development of new drilling techniques, improvements in refining processes, or the introduction of new products such as biofuels. 2. What is technology development in the petroleum industry? Technology development in the petroleum industry refers to the creation of new technologies that help to improve the efficiency, sustainability, and safety of the industry. This can include the development of new equipment and tools for drilling and exploration, as well as improvements in refining processes and the introduction of new materials and products. 3. What are the benefits of innovation and technology development in the petroleum industry? The benefits of innovation and technology development in the petroleum industry are numerous. They can help to reduce costs, increase efficiency, and improve safety and environmental protection. For example, the development of new drilling technologies can help to reduce the time and cost required for drilling and exploration, while improvements in refining processes can reduce emissions and improve the quality of petroleum products. 4. What are some examples of innovation and technology development in the petroleum industry? There have been many examples of innovation and technology development in the petroleum industry over the years. Some notable examples include the development of hydraulic fracking technology, which has made it possible to extract oil and gas from shale rock formations, and the introduction of horizontal drilling techniques, which have enabled more efficient extraction of oil and gas from reservoirs. Other examples of innovation and technology development in the petroleum industry include the development of carbon capture and storage (CCS) technologies, which help to reduce greenhouse gas emissions, and the introduction of biofuels, which are derived from renewable sources and can help to reduce the industry's reliance on fossil fuels. 5. What is the role of research and development in petroleum industry innovation and technology development? Research and development (R&D) play a critical role in petroleum industry innovation and technology development. R&D efforts are focused on developing new technologies and processes that can help to improve the efficiency, sustainability, and safety of the industry. These efforts are typically funded by petroleum companies, as well as government agencies and research institutions. In summary, innovation and technology development are critical to the success of the petroleum industry. By investing in R&D and developing new technologies, the industry can become more efficient, sustainable, and environmentally responsible, while meeting the world's growing energy demands. Section 39. An analysis of the current state of the global petroleum industry. The global petroleum industry has experienced significant changes in recent years due to various factors, including market conditions, technological advancements, and environmental concerns. This article provides an analysis of the current state of the global petroleum industry, examining key trends, challenges, and opportunities. Market conditions. The petroleum industry is influenced by global market conditions, including supply and demand dynamics, geopolitical factors, and economic growth. In recent years, the industry has faced challenges due to a combination of oversupply and weak demand, leading to lower oil prices. In response, major producers have cut back on production, and some have implemented production cuts to balance the market. However, the industry remains sensitive to global economic growth and geopolitical factors, which can impact demand and supply levels. Technological advancements. Technological advancements have also had a significant impact on the petroleum industry. Advancements in exploration and production techniques have enabled the industry to extract oil and gas from more challenging environments, such as deep water and unconventional sources. In addition, digitalization and automation have enabled the industry to improve efficiency, reduce costs, and enhance safety. The use of big data, artificial intelligence, and machine learning has become increasingly prevalent in the industry, providing insights and opportunities for optimization. Environmental concerns. Environmental concerns have become increasingly important in the petroleum industry, with a growing focus on reducing greenhouse gas emissions, improving sustainability, and enhancing environmental protection. The industry has responded by implementing more stringent regulations and adopting cleaner energy sources. The transition towards cleaner energy sources has created new opportunities for the petroleum industry, including the development of renewable energy technologies, carbon capture and storage, and hydrogen production. Challenges and opportunities. The global petroleum industry faces several challenges, including a shift towards cleaner energy sources, declining reserves, and increasing competition. However, the industry also presents several opportunities, including the development of new technologies, exploration of new reserves, and expansion into new markets. In particular, the transition towards cleaner energy sources presents a significant opportunity for the industry to diversify and expand its operations. The development of renewable energy technologies, carbon capture and storage, and hydrogen production provides opportunities for the industry to leverage its existing capabilities and infrastructure. Conclusion. The global petroleum industry is facing significant challenges and opportunities, driven by market conditions, technological advancements, and environmental concerns. The industry is likely to continue to evolve and adapt to changing market dynamics, as it seeks to balance economic growth with sustainability and environmental protection. The development of new technologies and the transition towards cleaner energy sources present significant opportunities for the industry to expand and diversify its operations. Section 40. A Guide to the Basics of Upstream, Midstream, and Downstream Operations in Petroleum Engineering. Petroleum engineering is a field that involves the exploration, extraction, and production of oil and natural gas. The petroleum industry is typically divided into three main areas: upstream, midstream, and downstream. Each area plays a crucial role in the production and distribution of petroleum products. In this article, we'll take a closer look at each of these areas and provide a guide to the basics of upstream, midstream, and downstream operations in petroleum engineering. Upstream operations. Upstream operations involve the exploration and production of oil and natural gas. This includes identifying and assessing potential drilling sites, drilling wells, and extracting crude oil and natural gas from underground reservoirs. Upstream operations are considered to be the most technical and complex area of the petroleum industry. The primary activities involved in upstream operations include 1. Exploration. This involves the search for new oil and gas deposits by conducting geological and geophysical surveys and drilling exploration wells. 2. Drilling. Once a potential drilling site has been identified, the next step is to drill a well to extract oil and gas from the reservoir. 3. Production. This involves the extraction of crude oil and natural gas from the well, and the separation and storage of the oil, gas, and water. Midstream operations. Midstream operations involve the transportation and storage of crude oil and natural gas. This includes the transportation of oil and gas from the production site to a processing plant, refinery, or distribution facility. Midstream operations are critical for getting the extracted oil and gas to the right location for further processing. The primary activities involved in midstream operations include 1. Transportation. This involves the movement of crude oil and natural gas from the production site to a processing plant, refinery, or distribution facility. This can be done via pipelines, trucks, or ships. 2. Storage. This involves the storage of crude oil and natural gas in tanks, reservoirs, or other storage facilities before it is transported to a processing plant or refinery. Downstream operations. Downstream operations involve the processing and refining of crude oil into usable products such as gasoline, diesel, and other fuels. Downstream operations are responsible for the production of finished petroleum products that are used in transportation, manufacturing, and other industries. The primary activities involved in downstream operations include 1. Refining. This involves the conversion of crude oil into usable products such as gasoline, diesel, and other fuels. 2. Distribution. This involves the transportation and delivery of finished petroleum products to consumers through pipelines, trucks, or ships. 3. Marketing. This involves the sale and promotion of finished petroleum products to consumers. In conclusion, the petroleum industry is divided into three main areas: upstream, midstream, and downstream operations. Each area plays a crucial role in the production, transportation, and processing of oil and natural gas. Understanding the basics of each area is essential for anyone interested in pursuing a career in petroleum engineering. In conclusion, we've explored the key concepts of petroleum industry. If you found this video helpful, don't forget to like, share, and subscribe to our channel for more content like this. Thank you for watching.